So in this next video we're going to run the ta-lib Bollinger Band methods. Bollinger Bands, if you're looking for a great resource, just simply go to John Bollinger's site, bollingerbands.com. So anyways, in this video we're going to run two different programs. I'm going to show you the completed programs and run through them. The programs will loop through different number of days. Bollinger uses 21 days. I'm going to have the code go through from 2 to 30 days. We'll use different types of moving averages. Bollinger uses exponential moving averages. I'll use all the moving averages available from ta-lib. And thirdly, we'll change the standard deviations. Bollinger uses 2 standard deviations. We'll do some type of iteration from like 1.5 to 2.5 and keep it at that. The first program will use numeric data, except for our attribute, the classification attribute, which we call result, will stay as a by or sell. And in the second program, I'm going to try to use nominal values for the data going into the attributes, usually like the price is above the upper band or above the middle band or above the lower band, and try to figure out some way to do a contraction, constriction, expansion of the bands, which is another factor that's used in the Bollinger Band methodology. Okay, on to the code. One of the first changes I've made to the program is how I built the classifying attribute, which I called result. The previous versions of the code looked at the close 5 days ahead and compared it to the current close. In this version of the program, before everything started, I calculate this 5-day moving average, and then in the point of the code where the result attribute is being built, I compare the 5-day moving average 5 days ahead to the current close. The primary change to the code is using the ta-lib's Bollinger Band method, which is called BB-ANDs. There are 3 changes to the argument list. The first 2 start and stop with the same, those 2 integers, but then we have the period of the interval for the moving average, and then there's 2 standard deviation values we can pass to it for the upper and lower bands. And finally, the 4th new argument is the moving average type, which is a value that's available through the ta-lib libraries. In the new code, there will be 3 new iterating loops. The first one will be for the moving average intervals for the Bollinger Band function. We'll change the values from 2 to 30, and we'll step by 1. The second loop will be for the standard deviation used by the Bollinger Band method to build the upper and lower bands. We'll loop from 1.6 through 2.2 and step by 0.1. And finally, the third loop will loop through all the available moving average methods available from the ta-lib library, and we'll simply just use a simple for statement pulling the MA type values from the enumerator. And finally, the last part or major change to the code is the way I realign the output values from the ta-lib methods. In previous versions, when I was using a simple moving average, we just used the interval value. But because some of the moving averages that we will be using generate a different offset, for instance the double EMA and triple EMA, the offset is not the same as the interval that we passed. So what we'll be using from now on is the outbeg object, and in that object is an attribute called value, which gives us the true offset. Alright, back over to the editor, and we'll go through what's been changed. Let's take a look at the attributes. we're still using current price, but then we're going to be adding upper band and the middle band and the lower band from the Bollinger Band method. And our classification attribute is still nominal buy or sell. Still loading the table. This is where I compute the 5-day moving average that will be used for the classification of a buy or sell, comparing the 5-day moving average to the current price. One small add I did to the CSV file was to put a header in there to make it easier for sorting. And here are our 3 loops. The moving average period from 2 to 30. The standard deviation from 1.6 to 2.3. And we'll use both that one standard deviation for both attributes that we pass to the method. And finally, the for loop to pull out each of the different moving average type methods available from ta-lib. We set up our output fields for the method, and here's the actual method call, core Bollinger Bands. Again, we pass a 0 start and the length of the array. That's our input, is the t-close, and then the attributes that we pass to it from the for loops, the period, the deviation, and twice, because one's used for the upper band and one's used for the lower band, and then finally the moving average method that's being called. Now we have to reset the output arrays so that the indexes line up, and again I use the outbeg objects value attribute to move the data into the correct positions. Building our training and test data. In this code, actually, I start creating test data after 2015 to give it more test data to play with. Build our instances. Call the random forest method to build itself, or the instantiation of it, and pass the classifiers to it. Build the instances for testing. Build our evaluator object, and then call the evaluation method using the test data. And we output the data again to the console and to our results CSV file. So let's run that. And as you will see, this takes a very long time. So I'll be right back. Okay, so it's coming to an end now. It's just about 2 hours. We started at 11:35. It's at 1:32 in the afternoon now. And we're done. Here's the output on the console. This is the moving average interval date. This is the standard deviation for the Bollinger Bands. This is the moving average method called, and then the precision weight. And let's just take a look at, we put that out to SPY result with numerics. So let's take a look at SPY results with numerics and open that with the spreadsheet. I think that's going to be okay. Max that. And here we are. Let's do a quick sort on average weight precision. And we'll do it descending. And let's hit the OK button here. And it's interesting to see that a pretty short moving average period and a smaller standard deviation using a moving average, which is simply a moving average of the moving average, gives us the best average weight precisions. Okay, now let's go look at one where all the attributes are nominal values, above and below the prices, above and below each of Bollinger Bands, and if the bands are expanding or contracting. So now we're going to convert the program to use all nominal values in the attributes. The first four numeric attributes will be converted to nominals, where the first three will represent the current price in relation to each of the bands, upper, lower, and middle, and the attribute value will be either above or below. The fourth attribute will be based on the upper and lower bands' distance from each other to determine if the bands are expanding or compressing, and they'll have three attribute values: expanding, in range, or compressing. So the looping logic will remain the same, as will the call to the Bollinger Band function itself. When rebuilding the output index, though, the code will now compute the standard deviation by passing the difference of each upper and lower value to the standard deviation function. You'll see that in the code. So we're back. Here's the program that's going to be using all nominal values. As we can see, the four attributes that were passing numeric values are now passing nominal values. First three above or below. If the price is above, in comparison to the upper, Bollinger Band is above or below it, and the price is comparison to the middle is above or below it, and likewise the lower Bollinger Band. The fourth attribute, compressing bands, has three possible values of expanding, in range, or compressing. The three four statements, not 12, but 3, 4 loops are the same, and the call to Bollinger Bands is the same. What's new is that there's this standard deviation function that I wrote, and if you're looking for a copy of it, I'll post it in the discussions area. While we are moving the output index back into the correct position, we also at that time enter each individual difference of instances of the upper and lower band. Here's a little tricky code I use. Instead of, I still have two string writers and print writers for the output of the attributes, but in this case I simplified the code by determining where I was in the data and setting another object which print writer to use, and then we output the attributes based on those two print writers, one of either the training or the testing print writers. And here is where the price to band comparison is made, where if the price again is above the upper, it's set to above or below, and likewise. Then to get the expanding or compressing of the bands, we have this logic. First thing we do is compute the difference, and we take that difference and look at the mean, and if the difference is greater than the mean plus 2 standard deviations, which is what this does here, we'll set the attribute to expanding. Otherwise, if the price is less than the mean minus 2 standard deviations, then we'll just assume that the bands are compressing. Otherwise, the bands are within range. And then we do the setting the classification attribute to buy or sell. Everything else remains the same. Just quickly, the output will be written to a file called SPY results nominal CSV. We're going to run this, and this runs a heck of a lot faster, probably 4 or 5 minutes instead of 2 hours as the numerics did. So here it goes. Okay, so the program's done, and that took a little bit more than 3.5 minutes. There's the console output, and we go to our CSV file. And let's sort that on average weighted precision. And again, moving average seems to be the winner. Chicken dinner. The standard deviation is a little higher than with the numeric attributes. Okay, so in the next video I will do a MACD process, which will require some changes to the way the prices are recomputed due to price splits or dividends. Until then, if you like what you see, hit that like button, okay?